Hey everyone, this is going to be the first video example problem using the TMR or isocentric dose calculation formalism. So please take a moment to read through the problem statement here. So as always, I like to start by writing down a few of the data points that we are given. So our calculation depth is 15 centimeters, monitor unit setting is 434, and our collimator field size is 20 by 20. And I also want you to notice that it says calculate the dose delivered to the isocenter, which is said to be at a depth of 15 centimeters. So whenever you see a sentence like that or a phrase that kind of implies a similar thing, that should tell you immediately to use the isocentric or TMR formalism for this problem. We're also given the calibration condition to be at an SSD of 100, with the field size 10 by 10 at a depth of D max, which is not an isocentric calibration. So something needs to be done for us to convert the calibration dose per monitor unit to an isocentric dose per monitor unit, which can be done using the inverse square law. So we just take the reference dose here, which is 1 centigrade per monitor unit, and multiply it by the inverse square factor, which is shown here. So we have 100 plus 1.5, which is 1.5 is the depth of D max, and 100 is our calibration SSD. And then we divide it by the source to access distance, which is 100 for most Linacs, and we square it. That's the inverse square law. And if you work that out on a calculator, you'll get 1.03 centigrade per MU being delivered to that point. And once again, I always like to kind of work through this. And so our calibration point is 101.5 centimeters away from the source, but our isocenter is 100. So we have to move the point closer to the source, which means our dose rate should go up, which it does. And so that serves as a reasonable check for you to perform in your head to make sure that you're doing that inverse square correction correctly. Now we can go ahead and put it in equation form. So on the top, I write down the generic dose calculation equation for the isocentric formalism, including all of the necessary factors that we need, and I just omit the ones that we don't need. So we have our isocentric calibration factor, our monitor units, TMR, and our scatter factors. And then in the second row, I just substitute the correct values for the field size and the depth. Notice here that we only have a single field size, which is defined by the collimators. And so the TMR will use that field size, as will the phantom scatter factor, because the point of calculation in this case is the isocenter. If it was something different, then we would have to take beam divergence into account to calculate the correct field size. But since we're at the isocenter, we can just use the collimator field setting, which also means that we can combine the collimator and phantom scatter factors into the total scatter factor, since the field size is the same. Just a little simplification there as well. And we can once again draw out the geometry here. So this is the reference condition. We're at an SSD of 100, our field size of 10 by 10, and our depth of 1.5, or D max, for the 6x beam. And now we can apply an inverse square correction, which we are going to need to move from this SSD calibration condition to this isocentric calculation. So we apply inverse square correction, and we can get the dose rate now at the isocenter using this inverse square correction. Now we can account for a change in the collimator setting by applying the total scatter factor. And so we just increase that jaw size, and we account for the differential amount of scatter coming from the collimator and also coming from the phantom. And now, of course, we can account for the depth change with the TMR. And so we change the depth of our calculation point and put it at 15 centimeters, which is what the problem asked for. And now our calculation geometry looks like this. And this is just a nice illustration of how we can perturb the dose under our reference condition to the dose given the geometry that we're trying to calculate in. And this is also a nice illustration of how we can go from a Linac that was calibrated at SSD and actually use it to do an isocentric calculation. And also notice that our source to calculation point distance isn't changing here. We're always 100 centimeters away from the source. Since we're doing an isocentric calculation, we're always staying at that fixed distance. And now we can go to our trusty beam data. So this is the TMR table here for 6x, and we find our correct field size of 20 by 20 and our correct depth of 15. And you can see that the TMR value is going to be 0.6874, which is shown there in where the boxes intersect. We can also do the same thing for our scatter factors. In this case, we can just jump straight to that last column where the total scatter factor is tabulated. And then we can put it all together. So we have our isocentric dose per monitor unit, our monitor units times the TMR times the total scatter factor gives us a dose of 324 centigrade. I apologize, there was a little error with my pen there when I was writing down the answer, but that does say 324 centigrade. So that was just an example using the isocentric formalism for dose calculation. This is a pretty straightforward example, and we'll get into a little bit more complicated example in the following video.